Good evening, everyone, and welcome to Social Flight Live. I'm Jeff Simon. We have a wonderful show for you this evening. The legendary aircraft designer Burt Rutan is here, and we're going to hear about his life, the aircraft, so many different things that have literally changed general aviation as we know it. So I cannot wait to get Burt on the show here and then to have all of you hear from him. Before we get started, just a few things. First of all, fall flying is in full swing and so many amazing events can be found on socialflight.com and the free SocialFlight apps for Apple and Android devices. We have just tens of thousands of events. There's so many cool things going on. There are pumpkin drops happening around the country. There's a pie-in, fly-in happening near here. There are just check it out. You can see all the fun flying events happening all over to get you out there and flying, which is our mission to support general aviation. And while you're doing that, please join the Fly to Win Challenge. We just gave away a Lightspeed Zulu 3 headset to William Dubois of Santa Rosa, New Mexico. And in addition, now we have a new Fly to Win Challenge period that just started, and we're going to be giving away a Lightspeed Delta Zulu headset on December 1st. That's the Delta Zulu with carbon monoxide detection, Canary technology that lets you look for leaks and carbon monoxide, things like that, and also the hearing acuity program that customizes the way that your hearing works. So very, very cool stuff. Tonight's broadcast is brought to you by Avidyne. Avidyne has some of the most amazing avionics. We fly behind them in the Bonanza, as well as what we're equipping this T-51D Mustang project here behind me. Their IFD 440, 540, and the 440, 540, and 550 are just truly amazing platforms that I just absolutely love to fly behind. I'm going to show you a couple things that I love about that really quickly here. First of all, you know, one of the best things is that you can interface with the IFD series any way that you want. There's hard buttons, there's touchscreen, there's a bunch of different things. And I personally use the keyboard all the time, which is mounted on the yoke. It's just enabled with Bluetooth. You can just type in a complete flight plan without a break, and it'll just go right into the system. It makes IFR navigation, really complex routes, extremely easy to do. It has synthetic vision on the 550 series that's built in, and also in the Mustang, we're doing it with a forward camera that will look forward there and show everything, and that's another feature that's available as an option on those systems. So big thank you to Avidyne for their amazing products and supporting Social Flight, making all of this possible. Now, to tonight's guest. Nearly 50 years ago, Burt Rutan turned the experimental aircraft community on its head with the VariViggen, a two-seat pusher aircraft with a Canard hanging out in front. The Canard would become synonymous with Rutan aircraft such as the Long EZ that literally revolutionized aviation with some of the most efficient and unique aircraft to grace the skies and fill the Oshkosh aircraft parking areas year after year. Burt's many contributions at home builders didn't just include aircraft designs themselves, but they also included innovative construction techniques that made it possible for people to build these aircraft at home without complex molds or tooling. That's what really made the difference. Now, not content with remaining in the GA realm, Burt went on to design iconic business aircraft such as the Beech Starship, as well as mission-specific, record-setting aircraft that included the all-around-the-world flying Rutan Voyager, high-altitude Proteus communications platform, and the Global Flyer. In 2004, he broke the final frontier with back-to-back flights of SpaceShipOne, which became the first privately built, flown, and funded manned craft to reach space. I'm going to bring him on the show now. Please welcome to Social Flight Live, the legendary Burt Rutan. How are you doing, Burt?
I'm doing great. You're looking good, Jeff.
Well, thank you so much for taking time out of your evening.
Probably, yeah. Okay.
I'm grateful for you taking time out of your evening to join us here on the show, and I am extremely conscious that there is so much to talk about in your life and career. There's just simply no way we're going to make it into one-hour show. But I want to start with something that is that kind of goes back to when you first started kind of designing aircraft and had this unique perspective of doing it differently, looking at everything differently than what all the general aviation aircraft were like at the time. Tell me a little bit about how you got started.
Well, I got started as a child. I was brought up in a Seventh-day Adventist home, and so I couldn't do the sports at school, and it wasn't until I was a sophomore in high school that I went to public schools. So I looked for something to do that was challenging at a very early age, and that is when my brother, who's 5 years older, would crash a model airplane, I'd pick up the balsa wood pieces and glue them together into something else and fly them. So very quickly, by the time I was 12 or 13, I was actually doing competitions. The local hobby store guy would drive me to the San Francisco Bay Area, and I'd come back with trophies and control line model airplane competitions. So I think because of the thrill of winning things and even beating the adults on this technology or this fun stuff, I knew right away I didn't want to do what my dad did. He was a dentist, and it didn't seem like a good thing to charge someone to give them pain. So I knew right away that I wanted to be an airplane designer, and that was reinforced when I was in my backyard flying a little airplane, a little model airplane, and two B-36 bombers flew right over my house. Now, they weren't pressurized, so they're low altitude, and the sound of those propeller blades, I've forgotten how many there are, but a bunch. If you heard it today, you would be mesmerized by it. So that really, I believe, is a time when I knew that I wanted to do nothing else but design airplanes.
Wow. Now, there's one thing to design aircraft in an evolutionary way, which there's thousands of aircraft designers out there that do every day and just refine things that look traditional. But clearly you are known for striking out in a very, very different way, focusing on canards, focusing on looking at problems differently. Did that start at the model aircraft part back then, or is there some point at which you remember looking at problems and solving them from a completely different angle?
Well, I like to, when the subject comes up, I like to think of the three C's. First one is curiosity. And curiosity is the reason that when I had an option on a new design, a new requirement, I would never pick the one that was conventional. To me, that was boring. I was curious to find if something else very unusual might be better. The best example of that is my Boomerang, which is my very best work in general aviation. This is a very unusual looking airplane, but it's the most efficient, longest range, it's the safest airplane there is, because it doesn't have an engine out failure process. In fact, you can fly at single engine, even at full aft stick, minimum speed, while you have your feet on the floor, not even touching the rudder pedals. So that's the most significant thing that I use as an example to say I tried something really different when I wanted to build a twin that was more efficient than my Defiant, which I had most of my flying time in.
So
the second C is creativity. You know, a lot of people are creative. A huge amount of people are very creative. But they generally, if they're trying things that are different and looking for a milestone, They usually fail to get it funded so it could be built and flight tested. So the third C I call courage, and that is the courage to ask someone like Paul Allen or Richard Branson or anyone really, or to ask Lockheed. And it takes my courage to ask them to try something that may not work. A little bit like Musk, he did things that may not work. That's why he launches almost all of the payload to orbit. He tried something that was seemingly impossible. And you also need the courage of the folk that are funding it. And if your customer, again, sometimes it's me, if your customer has curiosity and has courage, you can use your own creativity and do something fantastic. And I think history will show that the two projects that I'm mostly known for, the Voyager flight in 1986, a nine-day around the world non-refuel flight, and also, of course, the three suborbital space flights that we did that were non-government. Government didn't even know they were going on because that program was covert for the first two of its 3.5 years. I think the more significant thing might be that I'm working now on a design, and hopefully it'll get built, and it will be the 50th manned research airplane that I was either designed or at least did preliminary design and had one of my two companies build it and do manned flight testing. So that's my goal right now, is to not go out with just 49, but this nice round number of 50. So that keeps me excited now. I would be very bored in retirement right now if I didn't have in front of me a challenge to try something. And again, both of these designs I'm working on, they are extremely unusual.
What can you tell me about that project?
It's because I'm curious to see if this will work.
Are there any details that you can let people in on the most recent 50th project?
When I talk about something in the future, people seem to think that they have a right to know everything about it. And I think the reason is that, generally people that have a new airplane project, they'll build a mock-up and have a press conference, and they'll tell you how fast it'll go, right? And they haven't even started building the tooling for it yet. Well, look back at my 50-some years, and you'll find that the majority of those airplanes, you didn't even know about them until they had flown. Okay. And I don't want any help with these two, so it's closely held. And we have a covert place to fly up here in North Idaho, so I don't have to like reveal it like we had to reveal SpaceShipOne, because a lot of people are around the Mojave Airport. Well, up here in North Idaho, we have runways that are in forests, owned by friends. So if this thing doesn't work, I won't be that embarrassed by it, because you may not know much about it.
Fair enough.
And I am embarrassed because I talked too early on my 49th airplane, the SkiGull.
Yeah, the SkiGull certainly gets a lot of questions, and before the show we certainly got a lot about that. But before we go forward into some of those, I'd like to understand, when did you first I guess, really become interested in the efficiency of Canard aircraft? That seems to have been, of course, a signature of just about everything that you've done.
I was, by the way, I have a chapter about this. Go to Brab, which is burtrutan.com, and click on B-R-A-B, Brab, and read chapter 17. That chapter describes in detail the answer to the question that you just asked. The evolution of my interest in airplanes and the evolution of my interest in Canard airplanes, and everything that I did getting there. You know, so the short answer to it, ask it again so I'll be sure it's specific answer.
Let us know when you first became interested in canards as a foundation for your design, and how that kind of carried through.
I didn't do canards as model airplanes when I was a kid or even in high school. I didn't do anything canard. But when I got to college, I was in college at Cal Poly from 1961 until 65, when I got a bachelor's degree in aeronautical engineering. During that time, the Swedish government, they didn't fly it then, but they announced and showed the details of a future airplane called the Vigan. And it was, for its time, it became the most advanced fighter airplane in the world, in that it could operate in a short takeoff and landing mode because they operated off of roads, because their airports would be the first thing they'd lose if the commies came over the line, right? So it was S2LL, it was supersonic. It also had some phenomenal things that I was fascinated by, and that is it had natural stall limiting. You don't need a computer to keep it from stalling. Keep in mind, in those days, this was before the F-16. You didn't have computers to make the airplane fly right. You had to have good aerodynamics, not just to make it fly well, but for example, in the case of the F-4, where I did the spin program, that airplane could get into a flat spin, and the flat spin was always had ejections where you jump out of it and lose the airplane, because actually I was myself and Jerry Gentry in 1968 or 69, we were the only ones that were ever in a flat spin in an F-4 Phantom, followed by a landing on a runway.
Really?
We had a more sophisticated anti-spin chute or spin recovery parachute than the Navy had on theirs. That one didn't work and it crashed, but we got in a flat spin. I was in the back seat, and we started at about 40,000 feet, as I recall. I have all the data. I'm going to publish this data too, by the way, in Brab. And the spin chute worked, and we landed back on Edwards runway. And we had so much confidence that now we had a safe recovery from the thing that was killing, or not really killing because you have ejection seats, but there were 61 airplane accidents with F-4 Phantoms by the Air Force. 61 accidents that didn't have bullet holes in them. You lost 61 airplanes because of shitty flying qualities. Bottom line. Shitty mainly because they tried to make a bomber out of the Navy's interceptor.
Got it.
Okay. So anyway, that does that answer your question?
Yeah, so the Vigan basically was your inspiration.
It was. The Vigan was. And I was so lucky that I decided not to go into the Apollo program like everybody did. Remember, I graduated from college halfway between Yuri Gagarin's first manned space flight and the moon landing, 1965, right halfway between. And they were hiring non-engineers and teaching them engineering to try to get to the moon. You know, that challenge was just crazy. We go to the moon, right? Well, I decided to take my lowest paying job. My salary was $7,070 per year, and be a government worker that flight tests Air Force airplanes. And boy, it was the best decision I ever made, because when you're in testing an airplane when it's new, and you always have to change things to make it okay or to make it better, that's the best training for someone who wants to be an airplane designer.
Mm. That's fascinating. So clearly
the thing I was getting at, within the first week or two after I left my college and went to Edwards to take up this new job of flight tests, I went from Edwards Air Force Base over to Plant 4 in Palmdale, where the B-70 was built. And I watched the first flight of a B-70. And you could get real close to the runway there on the southeast side. And I watched this B-70 take off and just, you know, like this. And then it showed us that beautiful planform.
Wow.
And then within a year or two, I was in the back seat of an F-4 Phantom, number 2 for takeoff, and number 1 was a B-70.
That's amazing.
We were sitting really close to it, and it ran up its engines one by one, all either 6 or 8 of these big engines went into afterburner. And we had to lower the canopies on the Phantom, because it was shaking, it was hot, and we were concerned about, you know, getting immediate sunburn or something. So we lowered the canopies, and then it started its roll. B-70, you don't see much of it on the straight in view. Let me get the straight in view. And it rolled a long way down the runway, and then you saw this gorgeous planform of a B-70.
Wow.
If you don't know what a B-70 looks like, well, go to the Air Force Museum in Dayton.
Yeah, that's amazing. And so now before, so clearly the name Vigan showed up in your VariViggen design. That you still did while you were with Beatty. So tell me a little bit about your experience. What I assume that working at Beatty was your first kind of toe in the
during
water?
college, I built model airplanes of Canard airplanes, radio control, a couple of radio control models of Canards. And I was fascinated by, could I, on a light plane, instead of what the Swedes are doing with a fighter, could I make an airplane have natural stall limiting? Because getting too slow on that turn to final and having a departure there was the biggest killer in general aviation. So it was a safety thing that really drove me. I says, man, if I could make an airplane have natural stall limiting, that would do more than anything else to lower the accident or fatal accident rate of general aviation airplanes. So that, you know, that's a noble goal, right?
Yeah.
So I tested a tiny little model that was only 6-inch wingspan, and I had to rebuild the wind tunnel at Cal Poly to get it running. And I tested it there, and then I built a radio control model, a large one, and tested that. And I think one of the reasons that I was so fascinated to go to Edwards was not just the thing I talked about 2 minutes ago, but the fact that I would be up and close to the B-70.
Mm.
You know, we called at Edwards, we called the B-70 the savior.
Really?
Are you familiar with why we would call it the Savior?
I can only guess. Tell me.
Well, we didn't get a video of it at the time, but I did a reenactment of it in Dayton under the B-70 recently. The B-70 was put in a hangar, and they specially made it with instead of one big door for the tail, there were two because it had two big tails. And in those days, they'd build house trailers and put them together for the engineers just outside the hangar, or sometimes build a whole new building on the hangar. Well, B-70 sit really high off the ground, and it wouldn't take up any room in the hangar to put the engineering and flight test pilots and conference rooms and all of that just right inside the hangar. So someone who hadn't seen the B-70, seen just maybe pictures of it, which absolutely more than any other airplane doesn't give it justice. You'd go through a door to get into the hangar, which is a standard door like you have in a house. And you'd walk through a long ways. In other words, you're in the hangar, but you can't see the airplane. But you walk through clear to the end of this engineering and test pilot conference room area, and you go through another door that's no bigger than the door of your house, and you open that door, and right in front of you, at close range, is the nose wheel. You don't see the airplane, you see this nose wheel. And you look up like this, and you see these big square supersonic inlets, and you turn to the right and you see this beautiful serpentine nose. Oh, you've got a picture up, right? And the
Yes.
canard, and the nose wheel is back there right under the inlets. It's not up in the nose. And the effect that it had on me, and that it had on nearly everyone who saw it for the first time walking out of that little door, was Jesus Christ. So that's why we call the B-70 the Savior.
That's funny.
That's a true story.
That's really, really funny.
The people that do flight tests, they have different names for airplanes. Some of them are not politically correct, and nowadays you never learn what they are. But they don't. What was the airplane? It was called the Aardvark.
Yes.
That wasn't its official name, right? And the B-52 is called Buff.
Yep.
Which is not big, ugly, fat fella. Oh, there's a nose gear. Can your viewers see this?
Yes.
Okay, that door is right in front of that nose wheel. But anyway, when you're in Dayton, Ohio, go to the best museum in the world. Plan to be there at least 4 days.
Yep.
And walk up to the nose gear of the B-70 and pretend that you hadn't seen it and look up, and you might say, Jesus Christ. Because the B-70 was absolutely huge.
Wow. So tell me a little bit about, you're at BD at the time, if I have it correct, and that's when you first started working on your version of the Vigan, or based on that inspiration. And you've got what's shown right here.
No, that's not quite right. I started building the VariViggen in my garage in probably 62 or 63 in Lancaster, California. That was while excuse me, I'm wrong on the date. Probably 66 or 67, right in the middle of my 7 years at Edwards Air Force Base.
Oh, okay.
I had designed this airplane because, keep in mind, at work I had to sit in the back seat, and I didn't get to fly. You know, once in a while they'd let you fly for a while, but you know, I had to turn on switches and cameras and write down notes and all this, and once in a while I'll pull out this plastic bag and throw up in it, you know, and then kind of stick it underneath and hold it by the G suit, and the pilot, he knew what was happening. So when he'd pull off at midfield at Edwards, and he didn't pull off in the middle of the taxiway, he'd always pull out real near the end of it, so you could throw your barf bag out. Sorry about going around the barn there, but no, I built the VariViggen, and I had it essentially ready to fly, but not quite, when I decided to take a year off, a sabbatical. I definitely come back because I could get all my sick leave back if I come back within a year. I was going to only quit for a year at Edwards Air Force Base and come back because I had so much fun. I joined the local EAA chapter, and I got into home building, and I was building my own home built. Yeah, a pretty unusual one. And
Very.
the VariViggen. Oh, by the way, you mentioned the 50 years. It was actually 51 and a half years ago.
Wow.
that the VariViggen made its first flight. Wow. We had a big party in Mojave a few years ago. Let's see, it was 2019, to celebrate the 40th year of the first flight of the Long Easy. But for some reason, I forgot about the VariViggen being 50. It'd be a small party because not too many people have VariViggens. They're really hard to build. You can see mine at the EAA Museum in Oshkosh, Wisconsin.
Wow. This is here's an image that I had come across of a number of your designs.
Yes.
This is breathtaking. Take me through this.
Well, when you plan to put 6 airplanes in a formation, your biggest problem is finding 6 people who are checked out to fly all these unusual airplanes and have adequate formation skills. Now, this doesn't look like a Blue Angels formation when their wingtips are just a few feet apart, right? So the spacing on this was determined by the most limited experience that the pilot had flying formation. And then everybody else flew the same, to make it nice and symmetrical, to make it look good. This picture was taken by a Russian aerobatic airplane that did a big roll over, and he shot straight up from the airplane down onto the formation. This is an actual picture of a formation of the VariViggen, the Very Easy, the Long Easy, the Catbird, the Defiant, and the Boomerang. It's the first time that these airplanes had flown together, and it's, of course, really a neat picture, right? In fact, it's so neat that I did something that made them mad. I took my drone. I live on Lake Coeur d'Alene in North Idaho. I took my little Mavic Pro drone, and I flew it out, and I took pictures of the lake with my house in the background, and I took pictures of just the lake going straight down. And then I took a digital version of the picture that you're looking at right now, all 6 of them, and gave it to my son, who is a Photoshop expert. And he took the airplanes out of this picture and pasted them into the ones with the Coeur d'Alene, Idaho background. And he also put them real close together, like the let's see if I've got one here. Well, I think you can see it on my website, but they put them real close together in this close formation, as if they actually flew that close together. And of course, that's really a thrilling picture, but true, it's fake. It's Photoshop, right? He did a good job. I mean, each propeller blade, he actually did the fuzz and it is so good that you can't zoom in and see that it's Photoshopped.
Wow, that's really amazing.
So, I can send you a copy of that. It's
absolutely.
But at any rate, yeah, that's what was flying. Let's see, I had another home built as a Solitaire, but it's so slow it wouldn't fit in that formation.
You mentioned another aircraft which has always been my favorite, and you mentioned it's yours as well at the beginning of the show. I want to talk about it just a little bit more, and that is, of course, the Boomerang.
No. My favorite one is SpaceShipOne.
Oh.
This is my favorite General Aviation airplane.
Okay, fair enough. So the Boomerang, it blows my mind by its
view of a Boomerang. The other view shows it much better.
Yes, there you go. The beauty of it is in its asymmetry. In its there's nothing I can imagine that is more out of the box Burt Rutan thinking than this aircraft. Just like your shells behind you.
Would you believe it if I told you that this airplane flies symmetrically when it's important, when you're slow and have mid-control speed, and a Beechcraft Baron, which looks symmetric, is actually asymmetric. And the reason is when you fly slowly, you got your nose up like this, and the propeller blade coming down this side is going into the wind. And when the propeller blade comes around the other side, it goes with the wind. So that blade has more thrust for a few milliseconds when it's on one side and less when it's on the opposite side. Bottom line, the net result is the thrust line is not in the middle of the crankshaft of the engine. The thrust line is 9 inches to the right. Okay? Now this airplane, its CG is much closer to the fuselage than to the boom and baggage pod, or that other fuselage. But if you move both of those engines to the right, the airplane becomes symmetrical, whereas a Baron is asymmetrical. The Baron has a critical engine. It will depart from controlled flight and may kill you at a higher speed if one of the engines quits instead of the other one. And Boomerang's not like that. Of course, the Boomerang, the fact that you can fly it at full aft stick, absolutely minimum speed, where it kind of does a low bucking like the Long Easy or Defiant does when you're holding full aft stick. Full aft stick, feet on the floor, and you just fly it with your ailerons and elevator, and absolutely no way to depart it. You can make a real steep turn into the dead engine, and it just does it.
Do you remember do you remember having that idea and what kind of generated the essence of the Boomerang?
Well, my task, this was never intended for home building. It is far too complex of an airplane and expensive. You know, people complain that a used aircraft engine is unaffordable, but here there's 2 turbocharged engines. So you know this is not a cheap airplane, very, very expensive. At any rate, excuse me, what was the question again?
About the essence of designing the Boomerang, and you said it was a task.
The configuration. So what I did, most of my flying time was in the Defiant. which is a relatively safe because it's a push-pull, but push-pull has some huge disadvantages. There's a lot of propeller noise from the aft engine because it's going in and out. The propellers are going in and out of the wake of the wing. And so the propellers blades are forced fore and aft every turn. And that makes noise and it makes fatigue. And also, if you don't have a nice closure, like the back end of the Boomerang here, where it's slender, it goes down to a slender end, you have a lot of what we call base drag. So the Boomerang is highly optimized for low aerodynamic drag. And I had a few ideas that I could make big improvements to my Defiant, the airplane where I had most of my flying time in. And I tried to do everything that the Defiant didn't have. And there's absolute engine out safety for one. You know, a Defiant is like a Cessna 337 push-pull. A lot of times the accidents were because the pilot's taken off, climbing over the trees, and he loses an engine, and it doesn't turn left or right because it loses it, and he feathers the wrong engine, goes into the trees, and kills everybody. So you know, this airplane, of course, doesn't have that. You don't have to identify the engine. In a normal twin, you play this game called dead foot, dead engine. In other words, if you're slamming on a rudder pedal to keep it straight, the foot that's dead, you know, the foot that's not on a rudder pedal, is the side where the engine failed. So you won't feather the other engine if you just think dead foot, dead engine. But at any rate, I wanted long range, which is a safety thing. You know, the Defiant has 1,400 nautical miles range if you slow it down to its range, which is a lot. I know range is safety, particularly for people that aren't instrument rated or airplanes that don't have anti-icing and so on. And you go, if you can go a long way around the weather and still get home, that's a safety thing. You won't push the weather and beyond your capabilities, which is probably the biggest fatality reason that general aviation airplanes have.
Right.
So I wanted another seat. I wanted a lot of baggage. The Boomerang's 5-place, and the baggage area is all in that other. Well, there's baggage area in the fuselage side. And there's also that whole other side. It looks like just a slender fuselage. That's all baggage space, unpressurized bags. You can pull up 2 Cadillacs and empty both their trunks into a Boomerang.
Well, it's a remarkable design that again that just, it's amazing that that you came up with something that just defies symmetry, and yet it is symmetrical in like you said, in how it actually flies. And
because of my heart health, I lost my ability to qualify for an airman's medical. I lost that in the 90s, 98. And so I have not been legal as a pilot in command since 1998. I did discover something, and that is if you take most airplanes, and if you taxi them down the runway at a speed greater than the stall speed, and you go back on a stick, they'll actually fly without an airman's medical.
So the other thing real quick is,
I didn't do a lot of that. The people that worked for me thought I was too important to be going out and doing things like that.
Speaking of asymmetry, behind you is a bookshelf that is quite intentionally at the angle that it's at, and yet doesn't. Tell us about that, because as long as we're talking about boomerangs and asymmetry.
What do you mean by the angle that it's at? What angle are you talking about? Or you tilted so you don't need bookends.
Exactly,
That's
exactly.
what it is. Also, I measured all the books that I wanted there, and which, you know, you hardly ever use paper books anymore. But they overlap also in a different way, so that you can actually get more books on that part of the on that part if you do it that way.
I love that.
Well, to me, that's a conventional bookcase.
So let's talk for a minute about when you decided to switch gears and start heading for high altitude. Did it evolve through things like
airplanes that fly real high? Is that?
Yes, like tell me, did you first go to higher altitude and then go to SpaceShipOne?
There's a program called Tier 2 Plus, which was a military requirement. Tier 2 Plus went through all kinds of evolutions, and the net result of that is the Global Hawk. Now, everybody knows what a Global Hawk is. It's that very long range, high altitude. It'll go on up above 60,000 feet, reconnaissance airplane. And in those days, 60,000 feet was above where the Russians could shoot it down.
Mm-hmm.
You know, and so it was, you know, it had cameras that could give better resolutions than you get from satellites. I forgot exactly the years that we did Tier 2 Plus, but you could Google it and find out. What happened is there were 6 different companies that competed to build this thing. It was going to be a huge program. You know, Global Hawk is a multi-billion-dollar program, just the airplane, right? Mm-hmm. Not even including the payloads, the cameras, and so on. So everybody was, and when I say everybody, I'm talking about aerospace primes, were competing for it. And because it was easy for scaled composites to build lightweight, all graphite, all composite, high aspect ratio structures. And because scaled composites had already demonstrated that they could do extremely efficient airplanes with high L over D, long range, and so on, I ended up being on 4 of the 6 or 7 proposals. When I say being on, I'm talking about for the Lockheed Martin proposal, mm-hmm. It was my configuration, and we were to build the prototype. And it was unusual from the Global Hawk. It was stealthy. Now, the government couldn't tell me why that's not important to them. We found out much later that what they were doing to make a reconnaissance UAV stealthy was that C word, it was classified. So they couldn't tell us that they're already working on that. So I thought, hey, this is going to be a winner because it meets all the requirements for it was so many hours. I think it was like 48 hours endurance and long range, very, very long range. It had to go above 60,000 feet. So it couldn't get shot down. But okay, on the Northrop proposal, Scaled Composites was going to just build the prototype, but they would design the airplane. Mm-hmm. See what I'm getting at?
Yes.
And on the Orbital Sciences proposal, it was my design, and we were going to build it. So 2 of them, Lockheed Martin and Orbital Sciences, which is now part of Northrop, that was a huge job for Scaled. It would put Scaled in the big times with military, military assets, expensive airplanes, you know. Yeah. what I learned in designing something that would have that much payload, that much range, and could fly above 60,000 feet, I learned. By the way, there is an outfit that went into some archive and published these Tier 2 plus designs. I don't know a link of it now. It's been decades since I looked at it, but you can actually find these 4 or 5 different configurations, and one of them was well, they picked the Teledyne Ryan one, and it was the one that built the Global Hawk.
Mm-hmm.
Now, the main reason that Northrop bought Teledyne Ryan is to get the Global Hawk. Right?
Yeah.
And
so what evolved to get to Proteus?
Well, here's the thing. I knew by doing a lot of analysis and performance design, and you had to know that you could build that light enough, and you had to know exactly what the performance of the turbofan engines would be up at high altitude, which is very low thrust, above 60,000 feet. So you had an airplane that could fly with very little thrust. I knew all of that based on the work that I did to win the Tier 2 plus military competing. And knowing that, along came a little company called Angel, and their plan was to get broadband on, broadband in major cities. Now this is before we had fiber in the ground, and households or small businesses and whatever didn't have internet, so we designed for them an airplane that its mission would be, it would circle around in a, it'd circle around in I think it was an 8 or 9 mile radius or diameter circle, and it would fly for about 14 hours. And every 12 hours, another one would come up and join the circle, and it would take over. They're not shown on this picture, but there was a big dish underneath it that was tilted, and it was tilted so it'd be level when you're in this circle, okay? Mm. And also I couldn't have any of the airplane in the way of the signal. So to get the flying qualities right, I could put the wing mostly in the way, but the wing tips had to go down. Now the Proteus has a carbon fiber left wing tip and a fiberglass and what's the other material? Quartz, fiberglass and quartz, right wing tip. There's no fuel out there in these wing tips. So that would give me just one little piece of one wing that was mostly transparent in the way. Because you can't have people every few minutes when you go around this 8 mile circle get an interruption. So the bottom line, it was going to provide this, having 2 of these airplanes, and of course the pilots, they have to fly for 12 hours. And why is it piloted? Well, in those days, this was before Global Hawk. In those days, it was felt that it would be, you'd have to go away from the big cities, because if it failed, like UAVs failed very often in the early days, and it goes down, it's going to be into downtown LA or a school or whatever, just too dangerous. If it's a manned airplane, well, they do it all the time. So there's no issue about safety and it crashing in downtown Los Angeles. Okay, so therefore it had to be manned. It had to be 2-place because I wanted one of the pilots to rest or sleep, and the other guy being the pilot in command. Now, wow. I also had a bunch of other things that Proteus could do. And one of the things is it could put But by the way, keep in mind, it was designed with the knowledge that I had from Tier 2 Plus. Okay, but it was a totally different mission. This was not reconnaissance. This was getting broadband to the masses. The other things that it could do, and I listed, maybe you can see that on the internet by looking at early things. Wyman Gordon's website might still have it. One of the requirements it could do is, keep in mind, I was at Edwards during most of the X-15 flying, where Mike Adams, not Mike Adams, but Joe Walker actually flew above 100 kilometers on 2 consecutive flights in 1963, and he was an official astronaut. Now, the Air Force said, oh, if you go to 50 miles, that's good enough, we'll make you an astronaut. So there's about 8 or 9 X-15 pilots, and by the way, it flew 99 flights between, I think it was like 64 and either late 70s or late 60s or early 70s. I could, with this size of an airplane, it could be the mothership for a single place rocket that could be launched at 60,000 feet, and it could go above 100 kilometers, and it could come down, and it would complete the mission that SpaceShipOne did. Now, SpaceShipOne original design didn't have a wing. It had feathers that open up all around it. It looked like a badminton shuttlecock. That's why when this airplane changes configuration for entry, we call it feathered. Well, that doesn't make sense. There's no feathers on it, but the feathers on a badminton shuttlecock are actual feathers from birds, right? So at any rate, that's where the genesis of that word feathered reentry is. Anyway, it was going to be picked up by my neighbor's Huey helicopter. He was my next door neighbor at Mojave. He had gotten one out of Davis-Monthan, Huey, a Vietnam Air helicopter. And it would go onto a parachute, and he would tow this grappling thing, and he would grab a hold of the parachute, pick it up and bring it back and land it gently right at our front door, at our hangar. So that would be its recovery and so on. Probably the simplest way of doing it. SpaceShipOne was a much more demanding thing to do a Mach 3 airplane, and that would have the right stability and control for all of these Mach numbers, and yet would be a nice, real low landing speed. It was a simple thing. But one of my employees, while I was designing this, he came in and I showed him what I'm doing. By the way, I didn't show it to all my employees because they thought I was crazy to be designing a spaceship when the fastest airplane we ever had was the Triumph, which is a Mach 0.77. Now I'm here sketching up something that's got to go to 100 kilometers altitude and 63 miles and has to go Mach 3. That's enough that, hey, Bert's off his rocker. Don't tell him, he'll get mad, But one of my employees come in and says, Bert, why are you doing that? We're an airplane company. Put a wing on it. Let's land on a runway. And based on what Corey Bird told me, he later, by the way, he doesn't have a college degree. He later was president of Scaled and just retired a year or two ago. Based on a little bit of encouragement from him, I decided, yeah, we'll do a winged thing. And I didn't want to just build a composite X-15. I wanted something with very low ballistic coefficient. Think of throwing, X-15 is throwing a bullet at the atmosphere. The SpaceShipOne is like throwing a feather at the atmosphere. See what I'm getting at? It slows down higher up where the atmosphere gradient is less. So the amount of G's that you see, the amount of heating that you get on reentry, and you know, the SpaceShipOne can go straight into the atmosphere, right? There's no bad angle that'll make it dangerous. X-15 had to go at 40 degrees on reentry. And by the way, since you're flying a parabola, your boost is at 40 degrees up. So you go around a parabola and you come back in the atmosphere, now you're at minus 40 degrees, right? If an X-15 went to space by going straight up and it came straight down, it would be destroyed. Much too much structural loads and heating and all kinds of problems. So they had to fly it very carefully. SpaceShipOne, my goal was that you could fly the boost and then put it in feather while you're in space, and then break out your lunch and have lunch and let the airplane re-enter. Even though it has no electronic flight controls, doesn't even have a yaw damper, its flight controls are the same as a J3 Cub. You've got cables or push rods to the ailerons or elevons and rudders, and it had electric trim so that it could be controlled when the dynamic pressure was high going through transonics. But as it turns out, unlike what Chuck Yeager had on his breaking the sound barrier, he had to have electric control of the stabilizer in order to be able to control it. Well, SpaceShipOne, you had electric control of yaw and roll, and it was nothing more than a electric actuator that moved the whole stabilizer, and the elevator on the back is what's hooked to your stick. Okay, so transonic, you had to trim the whole works because you can't move the elevator. High Q and the center of pressure way forward. You could pull real hard and little would happen. So as it turns out, as you get to higher Mach numbers, what we call the hinge moment coefficient, the coefficient that tells you how hard it's going to be to pull the stick back and move the elevator, well, that coefficient stays very high. However, when you're flying out of the atmosphere, now your dynamic pressure, or what pilots would think of as indicated speed, right? Indicated speed is real low. In fact, when the rocket burns out on a SpaceShipOne, the indicated speed is only about 50 or 60 knots. Wow. Now, I don't care what the coefficient is, hinge moment coefficient, but if you're at 50 knots, you can move the elevator. You see what I'm getting at? Yes. So it's a real unusual design. A lot of people think it's just a normal airplane, but there's a lot of things that are unusual about it, and the only, you know, I've done several patents. Normally the customer wanted it patent. I didn't. I patent the Grizzly flaps and a couple other things, but the only patent that I ever made any money on was the feathering of SpaceShipOne, and Richard Branson bought the use, non-exclusive use of the feathering concept. And we were able to build SpaceShip2 after he paid some money to be able to use, there it is, yeah. SpaceShip2 is very much like SpaceShipOne, except the wing's on the bottom. And the wing is, first of all, there's a rocket motor in there. There's the solid part of the rocket motor. And I had to put the spar either above it or below it. I thought the biggest risk was going to be flying qualities for the feathered reentry. And by getting the wing above it, I got a lot more directional stability and pitch stability during reentry. So I did that knowing that it would have too much dihedral effect. Dihedral effect means that if you have yaw, the airplane could roll in the wrong direction. And the SpaceShipOne, for example, during boost, you control roll mostly with the rudder pedals, not with the stick. So things are very different, but they wanted, Richard Branson wanted his Virgin Atlantic airline pilots to be able to fly spaceships. And so the Spaceship Two had to be a very conventional flying airplane. When I say conventional, not helped with digital flight controls. Like the X-15 is totally unstable, but it feels stable. Spaceship Two even does not have a yaw damper.
Wow.
It's a manually controlled with electric trim for transonic airplane. And I'm kind of proud to have done that. I think it's the, well, yeah, I'm talking too much.
Not at all. That's why you're here. Well, the list of aircraft are just remarkable. You mentioned you mentioned things like the Grizzly. I mean, there's just so many just to run through for people that want to do more research. We've got quite a few people, of course, that want to know if there's any news on the SkiGull. Anything to say on that?
Before I answer that, let me point out, I started to say something and then forgot to earlier, maybe about 43 minutes ago, when I said that those two flights, the Voyager and SpaceShipOne space flights, is what I'm known for, but probably history will show the more important thing is that we did 49 different types of research airplanes. During the 80s and 90s, with a little bit of help from Rutan Aircraft Factory, you know, for example, the Boomerang is in there, and maybe one other airplane. With Rutan Aircraft Factory and Scale Composites are two companies on the Mojave Airport. We had a first flight on the average of one every 8.5 months of a new type, not just a new airplane.
That's amazing.
And of course, the most exciting thing you can do on an airport is to witness the first flight of a new type. It's not exciting for the pilot. He's too busy to be excited. But when you go out on a ramp and everybody goes out for the first flight of a new type, especially the VariViggen, they thought I was going to buy the farm trying to fly that thing. But anyway, okay, you're insisting on talking about SkiGull. Tell you what, I am not embarrassed by the fact that it's a failure. I made some big mistakes on the hydrodynamics. I tried to do something very different. I tried to have a long stroke, flexible carbon fiber skis so that it could handle rough water. My wife has a little amphibian, a Super Petrels made in Brazil. If the top to bottom of the waves is more than 9 inches, you're not allowed to fly it off the water.
Well,
unlike the what is that Icon, which is about the same class, 100 horsepower. Unlike that, it doesn't split the belly open if you fly it through rough water. But it's a real hard ride. It scares her to land in rough water. I don't know whether you realize, but the most well-known amphibian, of course, is the Catalina, the PBY. Okay. If you look at any PBY and look at its logbooks, it very rarely lands in salt water because it damages the aluminum.
Oh, did not know that.
Also, what is surprising, that huge airplane, the maximum wave height that it's where you're legal. I mean, obviously, when emergency, they'll put it in any kind of water. But if you're going to go and do a routine landing in water, the maximum wave height is 2.5 feet.
Oh,
and that huge
didn't know
airplane.
that. It was that enormous aircraft.
People, if you're the first time you fly in a seaplane, okay, you are shocked at how much it bangs, you know, because water is like concrete. And we're told when you're learning to fly a seaplane, look out in front. If that's concrete, would you land in it without breaking your landing gear? You know, if it's a land plane. If it's smoother to where, yeah, it's going to be hard on the gear, but I'll do it. That's kind of what you think about. Now, with small amphibians, what they do is they go into harbors or fjords, or, you know, upwind, or, you know, where you have protection of the wind. So right. You don't go out here and land. She doesn't go out and land her amphibian just in the middle of the lake unless it's really calm.
Right.
He goes and hugs the shore at which it's smooth.
Well, your designs are all there. Every one of them is a success in what you learn from it. And
what I was starting to get to is this subject of of using flexible water skis. See, there's no shock absorption on a float plane or a seaplane. In a landing gear, you got about that much stroke on the landing gear plus some on the tire. It's solid. You know, they don't have shock absorbers on the. I don't know why, but they don't have shock absorbers on the floats. Or on the belly, of course. So I wanted a good 3 feet of stroke, because I wanted to be able to go into an ocean swell. SkiGull is all the metal parts, unless they're line replaceable units, are not aluminum, they're titanium. Wow. So I found I couldn't even drill a hole in titanium, but I've got a neighbor who's the smartest guy in the world, and he has a one-man shop, and he can make anything out of titanium like it's butter. So he built all of the parts that are metal, you know, mainly landing gear and stuff. The flight controls of SkiGull are all carbon fiber. There's no aluminum in it.
Wow.
The stick and the yoke and the torque tube and the push rods and whatever. Well, it has stainless steel cables, but no, I'll tell you, it's real cheap and easy to build flight controls if it's aluminum. You go to Aircraft Spruce and you get the right size tube and you drill a hole in and put a bolt in it. I couldn't do that. I had to filament wind carbon tow to make an assured bond and so on. So it was here's a story. I made some big hydrodynamic mistakes. I was hard-nosed, thinking this is going to work, and the experts told me that that's probably not going to work. And I said, well, that's what everybody says about my airplanes, right? I didn't listen to them. But anyway, I spent 6 years, actually almost 7 if you include a full-scale hydrodynamic tests I did out in front of a speedboat of just the lower part of the airplane. The airplane was heavier than the tests that I did, and I made the mistake of saying it's linear. Like, for example, the hydrodynamic drag, if the airplane's 20% higher than, 20% heavier, that I'd have 20% more hydrodynamic drag. Seems logical. But my design of it, which is, it's actually a trimaran, the whole floats 40% of the airplane, and then there's 20 and 20 on each side. It's actually trimaran. The mistake I made is if I tell that in detail, you'll need another hour. But the bottom line, the mistake I made, I tried to do simple fixes, and I did that over and over again for years. I 6.5, maybe 7 years of my retirement I wasted on that damn airplane. and what I have, it's got the world's most efficient General Aviation engine, the fuel-injected Rotax. It's actually a motor glider, very long wings, and if your gross weight over the span squared is less than 3 kilograms per square meter, not area, square meter, you usually think of area, but span times span. If that's less than 3, then you can license it as a motor glider. And I was going to license it as a motor glider. And literally on the day the guy was coming up to license it, you know how the FAA comes in and looks at it and can't find anything wrong. So he says, yeah, experimental, amateur built. Okay. I realized, well, wait a minute, if I did that, you'd have to have a glider rating to fly it. I don't know anybody in North Idaho has a glider rating, and there's all kinds of people that have seaplane ratings. And so I thought, well, shoot, I'm going to just do experimental amateur built and not do motor glider, which also let me operate it heavier. But bottom line is I worked very hard in 2015 and 2019. I'm talking about just burnout like hard to get to Oshkosh in both of those years, and failed. I wasn't going to go to Oshkosh unless I could operate off the water. So I have a very long range, lots of baggage, 2-place airplane that can't operate off of water. Anybody wants an airplane like that?
Well, I mean, it's just another step in so many amazing aircraft, whether they meet their mission or whether they don't. And
by the way, don't jump on it because you think you want just a long range airplane that has considerably more range than your long easy. To get that range, you got to fly real slow. And in zero wind, which you'd be crazy to do it in zero wind, but in zero wind, your flight from Oakland to Hawaiian Islands is more than 20 hours.
Wow. Wow. Well, before we go, I just want to show everyone, I mean, go to burtrutan.com to take a look at, there's so much out there. There's so many different aircraft, and the stories go on and on. From the pond racer that we've got here, there's just so many things. I love this one, the Ares, the mud fighter, you know, that looks like an A-10, the type aircraft that you did. Of course, you were deeply involved in what you did with at the beginning of the VLJ era with Vantage and the V-Jet, things like that. There's just so many things, and you mentioned also the Grizzly, which we always see at AirVenture. I mean, there is no end.
First of all, Brab is free. You don't have to buy it like you did a book. If you go there, I think the document that shows the best pictures of all 49 of them and the date of first flight, the performance, it's just, there's 49 slides in I think it's PowerPoint or PDF, and you can look at all of them in detail.
So that's burtrutan.com, and BRAB is on the site. You can click on it. you can get all the information so that people can go and follow this and get so much more information about
It's one of the
everything you've done.
chapters, and there's 90 chapters in BRAB, and only I think eight or nine of them are published so far.
Truly amazing. Well, Bert, thank you for everything that you've done for General Aviation, and thank you for taking the time to join us here on SocialFlight Live and tell some of these stories.
Is that all you've got? I thought this was going to take at least 2 hours.
We'll get you back. How about that? That'd be wonderful. Well, again, go ahead.
Well, first of all, it's unusual that I do these. I mean, I was shocked to find my brother had done it twice, and I hadn't even heard of it.
He's coming back for number 2.
I generally, I used to give talks all over the world because they want to pay me a fortune to do it after SpaceShipOne and after Voyager. But I made a decision, particularly after I gave up on SkiGull, that I want to not be stressed out. I want to retire and enjoy retirement. I love it when people come here and visit me. We can sit, look at the lake, and chat. And when they do, I turn on a little app called Just Push Record, and it makes a transcript and an audio of the interview. I've done 95 interviews now. Just did one a few days ago. And I love that visit, but I don't like to travel anymore. You know, I had to do this bucket list excursion that I did all of September, where I went to Scotland, Iceland, Greenland, Canada, and ended up in New York. That was something that I had to do. It was my last chance to do it, essentially. You know, I'm 80. I've had very poor heart health. My sense of balance and my strength is way down. So I may be talked into doing another Zoom thing, but when people say, "Hey, come here and give a talk," and I say, "Nope, not doing it anymore. I want to enjoy my retirement."
Well, I don't blame you at all. But again, I am grateful that you've taken the time to come and share some of these stories with us. I'm an enormous fan. I love the aircraft that you've designed, and it's just spectacular. So I really encourage everyone out there to go to BurtRutan.com, check out everything that you've published there, which more and more is going to be added to, as you mentioned, because this is the best way. There's no paper book. This is the way to do it, is to go online and see this amazing life's work. And of course, if you have time, go to the Smithsonian and see all of your work that's hanging there, whether it's the Smithsonian, the EAA Museum, or other places. It's truly fantastic. So thank you.
You bet. I will be also doing something I've never done before, and that is putting out drawings of all 401 airplanes. And this is a list. I put model numbers on it. 401 airplanes I've done 3 views of, written down what the specs are, and maybe who the customer is or whatever. And maybe there's not a customer, but it's just a half-page sketch. If I do that, I put a model number on it, and I'm going to try to have a chapter to show all 400 of those eventually in BRAB. I have an argument with Scaled, who's owned by Northrop now, and they have lawyers, and they say, "Oh no, you can't do that because that's intellectual property of all these customers. You can't publish it." Like I can't do something to show the Starship when Beechcraft doesn't exist anymore, right? But I've found that when you get real old, your give a shit factor goes way down.
Well, I can't wait to see that as well. That's fantastic. That would be just like a sketchbook of dreams.
Actually, all you got to do at Brab, I hate to keep, it's like I'm selling something, but I don't make a penny on it. But first thing, look at the table of contents.
Mm-hmm.
And it's arranged in 9 or 10, I think it's 9 sections. And each section has a number of chapters. Okay. And I have published in there that you can read the section summaries, which gives you an idea of what's going to be in all these chapters of this section.
Right.
For example, there's a section on early life. There's a section in the Air Force during Vietnam. There's a section of all home builds, and that includes Beatty, actually, and a section on scale composites up until when I retired in 2011. I don't like to, I won't put out details on what they did after I retired because I don't have the same visibility, obviously. And I don't want to be like a lot of people out there that guess what's going on and try to write about it. I'm not going to do that. Right. So I'll let somebody else write about scale composites after 2011.
That makes sense. Well, again,
now,
it's
Stratolaunch happened. Stratolaunch, the world's largest airplane, happened a few months. Got a customer a few months after I retired. But before that, I spent 21 years doing preliminary designs for a large airplane that would launch orbital boosters. Okay, and I was hired by the customer after I retired, Paul Allen, to be on the board of Stratolaunch. So since I did interface as a board member, a board member would go to board meetings, and if he didn't like something, he'd take out his dick and pee on it, right? Or just tell him, you're crazy, that's too high risk. And I was known for doing that. But bottom line, because I had that interface, I do have a chapter on Stratolaunch.
Excellent. Well, that again, to everyone who's interested, it's burtrutan.com, and then on the site you'll see BRAB, Brab, and that is where all of this information is there. So again, Bert, thank you so much for your time. I'm grateful, and thank you so much for everything you've done for General Aviation. It's remarkable, and I'm truly in awe of your work and a huge fan. So thank you.
Okay, you bet. Thank you, Jeff.
Have a great evening.
Okay.
And to all of you, thank you for taking time out of your evening to join us here on SocialFlight Live. We are off next week with NBAA happening out in Las Vegas and lots of content that'll be coming from there. And then back on Tuesday, October 24th at 8 p.m. Eastern Time with David Copeland of Tecnam Aircraft. Going to learn about those amazing aircraft. We spent quite a bit of time with Tecnam when we were out at AirVenture, and I have to tell you, I was blown away. It is just, they're just so finely crafted and so cutting edge compared to so many other general aviation aircraft out there. It is amazing. We're going to get the inside story on Tecnam from David next on the 24th. Then we're off for the Halloween holiday and back on Tuesday, November 7th at 8 p.m. with aviation filmmaker Adam White of Hemlock Films. His films are remarkable as well as series. If you've seen the Restorers series or Red Tail Reborn and so many other things, it's just really great. So looking forward to having Adam on the show as well. Until next time, thank you all for joining us here on SocialFlight Live and for everything you do for general aviation. And I wish you all blue skies.